We are continuing our lesson in section 7.1. This will be the second of three lessons in this section, where we're going to continue to simplify rational expressions, and this process is typically going to involve factoring of any number of ways. If you are not comfortable with some of the factoring processes that are utilized in this lesson, there will be factoring lessons that will be posted, I anticipate, by this Thursday evening. That would be Thursday, January 16th. So if you're not comfortable with some of the factoring methods that are referenced here, please check some of those review lessons on factoring so that you have a chance to practice that, as well as looking on my math lab to practice some of the factoring problems that are available there. I will also be offering mini factoring lessons in class for those students who require that review to be successful at doing these problems. The easy part of this lesson really is once you have the factors, reducing. The difficult part for a lot of students is simply the factoring piece and when to do what type of factoring. And this will be discussed in greater detail as we go further into these questions. So for the next problem, we're going to explore question 36, and that's going to read as follows. 2t squared minus 6t plus 4 over 4t squared plus 12t minus 16. So this is the first problem now that we have trinomials present. Now, whether you have a binomial, trinomial, or polynomial of 4 terms, the first type of factor we always look to try to do is to factor out the greatest common factor. And in both instances, we have that. So we're going to look to try that first. So when we look at 2, 6, and 4 in the three terms, the greatest common factor of that should be 2. Here we have t to the second, t, but in the third term, there is no variable. Therefore, there is no variable to factor from this. So all we will have to factor is 2. So as we go through this, 2 times what will be 2t squared? That'll be 2 times t squared. Here, 2 times what is going to give me 6? That's going to be 2 times 3. I bring up the t. Plus 2 times what gives me 4? That will be 2. So in the top here, I write the factored form of this as 2 times t to the second minus 3t plus 2. In the bottom trinomial, we have 4t squared plus 12t minus 16. For 4, 12, and 16, the greatest common factor for those numbers should be 4. Because the third term does not have a variable, there will be no common variable factor to remove. So this is going to be 4. Now let's go through and see how we get what remains on the inside. 4 times what is equal to 4t squared? It's 4 times t squared. Plus 4 times what gives me 12? That will be 4 times 3t. Bring down the minus. 4 times what gives me 16? 4 times 4. So I'm going to bring this over here now and get 4 times t squared plus 3t minus 4. Now, we still have 2 trinomials here, and one technique we use for factoring trinomials is to look for 2 binomials that multiply to this trinomial. This type of factoring factoring a trinomial into 2 binomials is one that we'll explore in greater detail in the review sections in review videos that will be offered for this class in the upcoming days. So if we are looking further at t squared minus 3t plus 2, we're looking for a pair of numbers that multiply to 2, to positive 2, and add to negative 3. That will get for us the factors that we're going to use. So we have t squared. We obtain this by multiplying t times t. Here, for the second part of each binomial, we're looking for a pair of numbers that multiplies to positive 2 and a pair of numbers that adds to negative 3. Well, the only way to get a positive product is to multiply a negative times a negative. Well, you can multiply a positive times a positive, or you multiply a negative times a negative. The only way, however, to get a negative sum is, in this case, to multiply or to add 2 negative numbers. So two numbers that multiply to positive 2 are negative 2 and negative 1. Negative 2 times negative 1 will give a positive 2. Negative 2 plus negative 1 will give a negative 3. So we have the correct pair of binomial factors here. We will look at something a little different for the second pair of binomial factors for the trinomial below. We know that t squared is t times t. For this one, we're looking for two numbers that multiply to negative 4, but that add to positive 3. Well, the only way to get two numbers to multiply to a negative 4 is to have either a positive times a negative or a negative times a positive. However, we need the sum of those numbers to be positive 3 also. If we use negative 2 and positive 2, negative 2 times positive 2 will be negative 4. But negative 2 plus positive 2 will not give us positive 3. It will give us 0. So we have to find a different combination of numbers to use for this here. So we will have, in this case, if we try, for example, negative 4 times positive 1, that will give us a product of negative 4. But negative 4 times positive 1 would give us a sum of negative 3. So for this, we need a positive 4 and a negative 1, because 4 minus 1 is going to give us the positive 3 we need for the factors here. So now we have taken this trinomial below and we have factored this trinomial into two binomial factors. So to review the type of factoring we've done here, we first took each trinomial and we factored out the greatest common factor. Whenever considering factoring, we have to look for the greatest common factor first. After we factor out the greatest common factor from each trinomial, we then consider if we can factor the trinomial into two binomials, which we could in both of these cases. Now that we have this factoring complete, we can now simplify by reducing this in the following way. First, if I were to write 4 as 2 times 2, I can reduce the 2's in this way. But now I also have a common binomial factor from top to bottom in the form of t minus 1. We can also reduce these in their entirety. On the top, we will have left simply t minus 2. In the bottom, we have 2 times the quantity of t plus 4. You can leave the answer in that form. That is perfectly acceptable. You are not expected to distribute the 2 back through t plus 4 again. So we have taken this rational expression with two trinomials on top and reduced it in simplest form below in the form of t minus 2 over 2t plus 4. Let's take a look at an example of maybe a little bit simpler, but maybe some different factoring involved. We have a squared minus 1 over x plus 1. Or excuse me, let me revise that please. So it's not going to be that. It's going to be x squared minus 1 over x plus 1. So in the top we have a binomial x squared minus 1. In the bottom we have the binomial x plus 1. Neither of these have a common factor or a greatest common factor to factor. However, when we look at the top, we have this as a perfect square in the form of x squared. We have 1 as a perfect square in the form of 1, and the difference of these. The type of factoring that is used here is the difference of perfect squares. And this will be another type of factoring that will be discussed in the review on factoring polynomial expressions later this week. When we factor x minus 1, we follow the formula of taking the square root of x squared and putting that in the first term here. We take the square root of the second term, which is 1, and we put a plus and a minus here. And this will be explored again at a later time, but we can factor x squared minus 1 as the product of x plus 1 times x minus 1. We're going to rewrite this over again over x plus 1. Because we have the same binomial on top to bottom, we can reduce these And now we are left with this in a simplified form with the final answer of x minus 1. So we have taken the original problem of x squared minus 1 over x plus 1 and reduced it to its final form of x minus 1. Let's consider one more problem for this video here. This is going to be question 44. We have the problem 6x squared minus 54 over 4x squared minus 36. Again, the first type of factoring we're always going to look for is going to be for the greatest common factor. And in both the numerator and the denominator in these binomials, we have a greatest common factor present. In the case of 6 and 54, the greatest common factor is going to be 6. And we'll rewrite these as follows. 6 times x squared will give us 6x squared minus 6 times 9 will give us 54. So I'm going to bring this down and write this as 6 times x squared minus 9. In the denominator, we have 4x squared minus 36. Well, for 4 and 36, the greatest common factor for that is going to be 4. 4 times what will give us 4x squared? It's 4 times x squared. 4, and then we bring the minus down. 4 times 9 will give us 36. So now I'm going to write 4 times x squared minus 9 here. Now, for some of you who are strong in factoring, you may already notice that x squared minus 9 can be factored as the difference of perfect squares. However, in this case, since we already have a common factor of x squared minus 9 in the numerator and the denominator, we may simplify this by simply reducing this in its entirety before we even factor. If you were to make the decision to factor this and end up with x plus 3 and x minus 3 in the top and the bottom, both factors would simply simplify, yielding the same result we have here. We can further simplify what we have here, 6 over 4, into 2 times 3 over 2 times 2. By reducing the 2's, we are left with 3 over 2. So the original problem of 6x squared minus 54 over 4x squared minus 36 reduces to the much simpler version of 3 over 2. We're going to take a look at one more problem in this activity. It is a quick question, and it reinforces a principle we learned earlier in a problem on the previous video. We have 6 minus x over x minus 6. If you are looking for a greatest common factor, or perhaps to try to factor this by the difference of perfect squares, you'll find that that's not possible. However, because we have something that is of the form a minus b over b minus a, anything of this form in real numbers is equal to -1. And because we have a like being equal to 6, b being equal to x, a minus b over b minus a, this is going to simply be equal to -1.